know, they got me handcuffed. I'm down in central booking. Things are fucked up the way my future's looking. But I'm too fly, I'ma change this scenario.
Hello and welcome to the video on the Fundamental Theorem of Calculus, Part 1. Okay, so even though this sounds like super formal, like the Fundamental Theorem of Calculus, it sounds very monumental to me, but it's pretty cut and dry actually. So just in general, the FTC, this Fundamental Theorem of Calculus, it reveals the connection between two major things that we do in calculus, differentiation and integration, okay? Alright, so here's part 1. This is what part 1 is basically saying. So FTC, Fundamental Theorem of Calculus, part 1. And I'll use a Roman numeral because I feel like this situation calls for formality. So part 1, so basically it states that, assuming that our f of x, so that some function is continuous on closed interval a, b, so a to b, including the endpoints, then we can say that if our f of x, capital F of x, is an antiderivative, which we've learned about, antiderivative of our f of x on that same interval, on a to b, then we could say that the integral from a to b on our interval of lowercase f of x dx is then equal to the antiderivative, right? And then because we have bounds here now, that this makes it a definite integral, we're going to say this vertical line here means evaluated at or from a to b, okay? And then we can also replace this with f of x is equal, evaluated at x equals a to x equals b. That means the same thing, but we usually denote it like this, so we don't have to write the variable. Anyways, so then from that we can say that this is equal to f, capital F of b minus capital F evaluated at a. Okay, so that's basically it. That's the statement of the Fundamental Theorem of Calculus, Part 1. This is just saying now that we're dealing with a definite integral, meaning that we do have these limits of integration, that means that once we find our antiderivative, once we integrate and we find our antiderivative, it's basically this integral here on the left is going to be equal to that antiderivative evaluated at the top or the upper limit of integration, upper limit, and then subtracting when you plug in that lower limit of integration into your antiderivative. Okay, so this is the all-important equation for the Fundamental Theorem of Calculus Part 1. So from a to b of a certain function is going to give you the antiderivative evaluated at from your lower limit up to your upper limit. So that means the same thing as saying you're going to plug in the upper limit first into your antiderivative, then subtract your antiderivative when you plug in your lower limit. Okay? So let's do an example of this. That's pretty much it. That's what this section covers. So if we're going to do an example, we're going to, let's say we want to calculate the area under the graph of, and I'll give you a function here. So whenever we calculate area under a graph, that means integration, right? That should ring a bell. So under the graph of f of x is equal to x to the third, let's say, over an interval of from 2 to 4. Okay? So if we're going to do this, we basically just set it up as such. So we have the integral from 2 to 4 of our f of x dx, and now for f of x we can plug in that x to the third. So we get 2 to 4 of x to the third dx. Okay? And then now we just go ahead and evaluate. So we have first of all, we just keep those limits of integration in mind, but we're going to deal with our integrand first, okay? So if we integrate that, we have to use the power rule, so we add 1 to the power, and then we put the reciprocal of that power on in front there, okay? And then instead of writing the plus c, so instead of writing that, we're not going to do that, we're going to say this is evaluated from 2 to 4, because we do have those limits of integration, okay? So now that we have that, this notation here, so 1 over 4 x to the fourth, evaluated from 2 to 4, that means we're going to plug in this guy first, and then subtract when you plug in this guy, okay? So this is going to equal 1 over 4 times 4 to the fourth, okay? So we plugged in our 4, and this is, we're going to subtract 1 over 4 times 2 to the fourth, okay? So this is basically our capital F of 4 and capital F of 2, see that? Okay, so if we continue simplifying here, we basically just get, so this one can cancel, and that'll be 4 to the third. And then here we get that we can cancel some things as well. but this is going to be a 4, and then this will be 2 to the second. Okay, so we get 4 to the third. That's going to be a 64. Then we have minus 2 squared, which is a 4. So our final answer is going to be 60. That is the area under x to the third graph over 2 to 4. So a special case to note is when we have ln of x as the antiderivative, of an integral. Antiderivative. Okay, so what this would look like is when we have our, so now we have a to b, and the only thing that changed was we added in those limits of integration. But when we do this, this is basically saying the integral from a to b of x to the negative 1 dx, and we all know that the integral of this, or the antiderivative of this guy, is ln x, so ln absolute value of x, and instead of writing that plus c, because we have these limits of integration, we're going to evaluate our antiderivative at each of those points. Okay, so we're going to get that this is equal to ln of absolute value of b minus ln of absolute value of a, and according to the properties of logarithms, we can actually combine these, right, because of this minus sign in between, so this becomes ln of b over a. Alright? And that's basically it. So it's just saying when we start with something like this, it's going to equal this as the final answer. So let's see an example of that real quick, and we'll wrap up this concepts video. So let's say we're given the integral from 2 to 6 of dx over x. Okay, so this is basically saying integral from 2 to 6 of x to the negative 1 dx. So this is going to be ln of x evaluated from 2 to 6, and this is equal to an ln of 6 minus ln of 2 when you plug them in, right? So this is with 6 plugged in, and then we're going to subtract from the integration, from the formula, from the fundamental theorem of calculus, part 1, and then we're going to subtract when we plug in the lower limit of integration. So then this is going to turn out to be ln of 6 over 2, which is ln of 3, and 3 is already positive, so we can just write a 3 there. So you can either make this your answer, or we can plug it into a calculator, and we get 1.099 about. Okay, so both of those are correct answers. Alright, and the last thing, I just want to give a little note on integration in general. A lot of applying this fundamental theorem of calculus, at least part 1, is just knowing how to approach different kinds of problems, like being thrown different formulas and stuff, using the same integration techniques, right? So once we have those limits of integration, you just find the antiderivative, and then we evaluate at the upper limit of integration, and then we subtract when you evaluate at the lower limit of integration. Okay? And don't worry, we'll work through a couple more practice problems in the practice problems video. So I hope that helped, and good luck on your homework.
Happened when I went to LA, mixing shit up. No, not there, I got family. Nothing happened. Mind your business, yo, step. You know we connect. JFK to LAX.